Good morning, everyone, and welcome to our webinar on sulfur management. So today we are going to talk about how we can reduce sulfur, focusing on microbial control and looking at the entire winemaking process. So my name is Églantine Chauffour. I'm the winemaking product manager for Bucher Vaslin North America, representing La Motabier, and I will be your speaker today. So before we dive in the topic of the webinar, let me introduce you the two partners. We have Bucher Vaslin, designer, manufacturer, and seller of material for grape and wine processing since 1856. And then we have La Motabier, renowned winemaking product for their premium and high quality. They have been founded in 1878 in Bordeaux, so 140 years of expertise and experience in Europe. We are now making it available for you in North America. As Bucher Vaslin in North America is expanding their portfolio, we are actually not only distributing Bucher Vaslin equipment, but also La Motabier winemaking product, Coastral bottling line, and Caso wine pump. So you can find all our products on our website at bvnorthamerica.com. Okay, so now let's talk about sulfur and microbial control. So basically, sulfur has been the first additive that we used in winemaking, and it is still a very common additive used for its antimicrobial and antioxidant approach. But now it's kind of on the spot, and reducing the use of sulfur is in the mind of every winemaker. So the interest of reducing sulfur is actually coming from mostly a customer concern. So consumers want more natural, allergen-free, organic certified products. So the media is also blaming sulfur for causing headache when we drink red wine or white wine. It's so basically the consumers are aware that sulfur is used to make wine, and they are blaming sulfur for many reasons that are not always justified. But that's a consumer concern. Consumer wants sulfur-free wine. Then there is also some technical aspects. So sulfur has actually some side effects and has its limitations. Sulfur can act as a solvent and will extract more color, or also phenols, so which could be good in some way in red wines, but it's usually something we want to avoid on white wines. Sulfur can inactivate thiamines, which is essential vitamins for the yeast. Sulfur will bleach color, so it will bind with anthocyanin and make an anthocyanin colorless. Sulfur will favor the synthesis of H2S. The yeast can actually assimilate sulfur and eject it or rejected it as H2S. Sulfur will lower the redox potential of the wine or on the juice, which will enhance or favor the production of reductive compounds and of aromas. But mostly, sulfur is actually not always effective. So we use sulfur as a multitask agent for its antioxidant, antimicrobial effect. But we have to see that, in fact, it's not always the most effective antioxidant or antimicrobial. As you can see here, so if we look at sulfur in wine, there is different forms of sulfur. When we add sulfur into the wine, we have a part that gets bound or combined with compounds. So the bound sulfur is actually completely useless or inactive in wine, and sulfur will bind strongly with acetaldehyde, but also with pyruvic acid, oxoglutaric acid, diacetyl galacturonic acid, oxogluconic acids. All these compounds are present in wine or juice when the yeast or bacteria are stressed, or when there is oxidation, or when there is botrytis. Okay, so that's something very important to keep in mind, because if you do want to just reduce sulfur, you want to make sure your sulfur is as efficient as possible or as effective as possible. So you want to reduce the amount of molecules that will bind sulfur. So we'll talk about this. Then if the second part of the sulfur is going to be the free part. And if we look at the free part, so the free part is effective as antioxidant, antioxidasic. The only form that is efficient as antimicrobial is molecular sulfur, which is where I would like to focus your attention, since today we are talking about microbial control. So molecular sulfur, so a good molecular sulfur would be 0.6 to 0.8 milligram per liter to have a strong antimicrobial effect. And unfortunately for us, or I would say like just how things happen, molecular sulfur depends on the free sulfur and on the pH. So as climate change and pHs are increasing, in average, we are actually having more and more trouble to protect our wines for as antimicrobial effects with sulfur. The reason is that, for example, if you look at this graph here, if we take a wine at a pH of 3.8, we would actually need 80 ppm of free sulfur, not total, free sulfur, to be covered as molecular sulfur and have a good antimicrobial effect. 80 ppm is very high for a free sulfur, and it doesn't really make sense to have a wine aged at 80 ppm of free sulfur. It would bleach the color, it would smell only sulfur, and it will also inhibit every reactions of aging. So it would not really make sense. So basically what I'm trying to say here is that alternatives to sulfur are needed. Yes, for the consumer perceptions, and consumer wants to hear that we are trying to reduce sulfur in the wine, but also because sulfur has some side effects that are negative, and it's not always effective, and it's not effective in high pH wines, which is now a concern, more and more a concern with climate change. So even with its limitation, it's not so simple to find alternatives to sulfur. Finding alternative has been a challenge for researchers and winemakers since a while, but we are getting there. We finally have some answers for you. Okay, so let's look at the winemaking process. And so sulfur would be used on grapes for its antioxidant effect, antioxidasic effect, antiseptic effect, and also sometimes as a solvent or extraction. For each of these actions, we developed alternatives, such as antioxidant effect can be achieved with the use of tannins or sulfur peptides, such as glutathione or ascorbic acids. Antioxidasic effect on grapes can be achieved and will actually be better than sulfur with tannins and fining agents based on bentonite to remove lacase and polyphenol oxidase. Antiseptic effect, which is where we will focus today, is gonna be, we can find alternatives to sulfur with microbial competition, or Chitosan, or even lysozyme. And then the extraction part of it, we can use maceration enzymes that have been actually developed for this action that works much better than sulfur. Today, we are gonna focus on the antiseptic effect. We actually did other previous webinars on oxidation management and phenolic compounds that will give you some answers on the other actions. The first and obvious point in microbial control that has to be kept in mind for the full process of winemaking is actually to have good hygiene and sanitation procedure. Okay. The second most important point is going to be to work with quality fruit or quality grapes and sort out the contaminated or not healthy fruits. So that's the idea here is that on grapes, that's where we have the biggest population of unwanted microbes and spoilage microbes. There is a huge varieties of non-Saccharomyces yeast and bacteria that are present that can spoil the wine, that can cause stack fermentation, that will open the window for spoilage later down the road. So we really want to focus on the grape aspect and controlling microbes as early as possible to prevent any issue later down the road and to make microbial control much easier as we go. Okay, so sorting is a very strong option because we will reduce basically the population of microbes on grapes. We will reduce the amount of contaminated grapes, will reduce the amount of open berries that will be having a stronger or higher load of microbes. Sorting options, you have different options. You can use sorting tables, vibrating, manuals, or mechanic. You can also go all the way to optical sorting, which is giving you extreme accuracy. Bucher Vaslin has equipments for different winemaking design and different needs. So please feel free to visit our website at bvnorthamerica.com/reception. To have more information, you can also email me, and we are very happy to give you as many information as you need. But sorting is definitely a very big step into having quality grapes and reducing the microbial control, the microbial contamination. You will also find videos of our sorting tables and before and after the quality of the fruit on our YouTube channel. Okay, so once the grapes are harvested, sorted, and maybe washed, we have few options here. We can use antimicrobial agents such as sulfur, chitosan, or lysozyme. I'm not going to talk about sulfur since we are trying to go towards alternative to it. So lysozyme and chitosan are actually good approaches that we will look at for wine aging. On grapes, we do have a better solution, which is the bioprotection. Bioprotection is a natural way to inhibit unwanted microbial development. It's basically microbial management by mastering colonization. So we are working on microbial equilibrium to always have a positive dominant population that will inhibit the development of unwanted microbes. This technique is very ancestral and is used in many industries. Okay, so the main question here is which microbes should we use that will be dominant, will be positive, and will not inhibit fermentation. So on winemaking, we want to select a microbe that has a strong implantation, a dominant population that will inhibit the development of other microbes without inhibiting Saccharomyces or without inhibiting the positive microbes that we want to ferment, will not have off-flavor production, and will not have fermentation capacity, because that's not, we are not talking about inoculation here, we are talking about bioprotection. So putting a microbe that inhibits the unwanted one, and then you will ferment with what you want. Okay. Also, the fact that there is no fermentation capacity means we are not reducing the nutrient content of the juice or of the grapes. So knowing this, basically there's many studies that has been made on bioprotection that show that Metschnikowia Pulcherrima, let's call it MP, that MP is the most interesting species that check all these requirements in winemaking. So knowing this, Lamotte-Abier developed our Excellence Bio-Nature, which is a pure Metschnikowia Pulcherrima, a pure MP, organic certified, that is used on grapes for bioprotection. So Bio-Nature has been selected to have no fermentation capacities, no inhibition on Saccharomyces cerevisiae, which means you can inoculate and go through fermentation with no problem, but you can also let your fermentation go native. Strong dominance, strong production of pulcherrimine, that is the reason why it has an antimicrobial effect. Metschnikowia Pulcherrima produce pulcherrimine, okay, which is this molecule here, but that's also, when you look at the plate here, that's how we recognize Metschnikowia Pulcherrima. As soon as you plate, the colony will appear orange or brown. Pulcherrimine is a pigment that's in a media, culture media, appeared orange, not in wine. But it is a pigment that is a toxin for the other microbes, so for the non-Saccharomyces yeast that inhibits their development. So basically, by having a strong producer of pulcherrimine in the environment, we are inhibiting all the development of the non-Saccharomyces yeast and bacteria, which helps bioprotection and helps Saccharomyces to take on. Also, as any Metschnikowia Pulcherrima, there is glucosidase activity, so we do have a positive aromatic impact, in fact, with release of more varietal characteristics, varietal aromas. No flavor production, resist to difficult condition, except alcohol. It will die as soon as you have like 3% of alcohol. And our is organic certified, and it's a non-allergen product. Okay, so concrete result, and I was thinking to actually show you just a result on wine. This is a trial done in 17, but we did actually many trials last year also in USA and this year, where we have consistent results, where we compare sulfur versus no sulfur plus bio nature. So if you compare the red line here with the green line is the bio nature with no sulfur. What you can see in a consistent way that there is always less VA, less ethyl acetate, cleaner wine, healthier fermentation, better sulfur efficacy when we do add sulfur, because we have less combining molecule with sulfur produced. But also, I mean, look at the tasting here. The wine appear more complex, less faulty, more balanced, more persistent, more round, more appreciated, with a stronger aromatic intensity and cleaner. This can be due to the fact that we didn't put sulfur, but also if you compare the dark red, this is no sulfur with no bio nature, and you can see that there is still a big increase when we use bio nature. Okay, so final wine is actually very positive in terms of organoleptic effect. And if we look at the analysis, we obviously have less sulfur since we didn't put it. We have less acetaldehyde produced. And here the line of the estimation of the TL35, this is how much sulfur we need to add to actually reach 35 of free sulfur. And you can see that we need less sulfur with the bio nature no sulfur than with the modality with just sulfur. So this is one result of trial, but as I was telling you, the results are very consistent. And actually today we have Casey Di Cesare that is connected with us. Casey is assistant winemaker at Child Vineyards, and he did extensive trials on no sulfur winemaking last year, and he's doing it this year again, and he agreed to share his experience with you today. So thanks, Casey, for being here, and I'm gonna let you share your experience with everybody now. Thank you, Casey.
Hi, Eglantine. Thanks for having me. Hi, everybody out there. Yeah, so with the help of Eglantine last year, we did a no SO2 trial where we used the BioNature in one fermentation, and we used Chitosan, which I know is Eglantine's going to talk about on future slides here, and then the last we used a just standard 50 ppm SO2 addition standard fermentation. So we got about 75 tons of Petit Syrah from our Hames Valley vineyard, and we split that between 3 different open tops, 25-ton open tops, and the juice analysis for all of it was basically the same starting out. And so yeah, we added 10 grams per liter of Chitosan in one, 5 grams per liter of BioNature in the other, and 50 ppm of potassium metaphite sulfite in the third. We did other antioxidant treatments with tannins throughout the process, but in terms of antimicrobial, so after doing that, a day later, we added 1 pound per 1,000 of an organic yeast, and then we added a nutrient about a third Brix drop. Fermentation for all 3 were super clean. Fermentation rates and curves were basically identical. You know, we had some concerns going into the whole process. You know, what is the interaction with SAC going to be like? What are the kinetics going to be like? You know, Chitosan had, you know, it's a gram-positive, gram-negative kind of broad spectrum. So is that going to affect, you know, malolactic bacteria, secondary fermentation? You know, how clean will the wine actually be in terms of VA, EA? And then kind of what's the final sensory of the wine going to be like? And really through the whole process, the interaction with Saccharomyces fermentation was super clean. With the BioNature, it actually finished a day sooner than the other 2. Which was cool to see. Secondary fermentation for all was also basically the same amount of time. There wasn't really any inhibition there. In terms of cleanliness, all of the 3 lots, the BioNature and Chitosan, had lower VA, less acetic acid bacteria, and none of the 3 had any EA. and there were no other, and with scorpions, there were no other spoilage microorganisms that made their way through the fermentation. And then we let the wine sit and barrel topped up with some additional tannin adds, and we tasted through about 6 and then 8 months later. And all the wines were really, they were different, but all were clean. I think we found a little bit of difference with the Chitosan. It kind of softened the wine a little bit and brought out a little more red fruit aromas. The BioNature actually added an interesting floral kind of violet quality along with red fruit, and the SO2 was kind of our standard classic, a little more on the black fruit side of Petit Syrah. All the wines were different, but they were all good. And so we were really happy with the experiment. So we're playing some more with the BioNature this year, with different ferments, seeing if we can do it on Pinot Noir and get some more color without adding any sulfur. So yeah.
So great. So thanks, Casey, for this. This is very interesting trials, and basically, as I was telling you, very consistent. So what we are seeing here, we saw it in many different wineries with different grape varieties and different conditions. To answer the question on application and the use of BioNature, BioNature can be sprinkled directly on grapes, no need of rehydration. Can resist to pretty wide temperature range from 35 to 85 Fahrenheit, resist easily to 60 ppm of sulfur. So if you don't want to completely eliminate sulfur, you can add BioNature plus sulfur and you will increase your antimicrobial protection. And it can resist to a low pH, so lower than 3 is actually okay. You want to apply it as early as possible, which means if you do have grape transportation, you want to apply it in the vineyard at the picking, in the picking bin. So your grapes are protected during the transportation. If you have your vineyard right around the winery, you can add it right after the steaming or fruit processing when you are going in the tank. That's for red wine, but you can also use it on white wine. And this will be same thing in the picking bin if you do have transportation, in the press pan if you don't have transportation, but you want to make sure you're protecting. No problem with white settling, since it's not fermenting, you will not have production of CO2. Dosage 40 to 60 grams per ton or 5 to 10 grams per hectoliters. Then why do we use it? We use it to reduce, replace, or complement sulfur for microbial control. So on red, also to limit the sulfur bleaching effect. On white, to limit the extraction of phenolics due to sulfur use. And in general, to limit the production of SO2 combining molecule. We use it to protect grape during long transportation and cold soaking. It will prevent VA, ethyl acetate, and other off-flavor production. It will limit the consumption of essential macronutrients by spoilage microbes. As Casey said before, he realized that the fermentation actually took less long, and using BioNature shortened the lag phase of the yeast. And this completely makes sense because basically BioNature is not going to consume any nutrients for the yeast, but it will help inhibiting the competition. So Saccharomyces doesn't have any competition, and Saccharomyces still have full nutrients for our development. So if you do inoculate, you will have a better implantation of Saccharomyces. And if you do ferment native, that's the best antimicrobial you can use, because it will help Saccharomyces to ferment and be dominant. So you will shorten the lag phase and favor native fermentations. It will limit the development of spoilage microbe at the early stage, which we consider as prevention. You want to control your microbes as early as possible, since they come with the grapes. Grape protection is the essential step in the full winemaking process. Okay, and again, it will favor also fermentation, and it will help having a healthier and better alcoholic fermentation. So if we keep going through the winemaking process, actually, as we are talking about bioprotection, control of microbial flora and managing equilibrium of population, we have bio nature first, then as soon as fermentation starts, alcoholic fermentation starts and alcohol is present, MP, or Metschnikowia Pulcherrima, is going to die and Saccharomyces will take over. So to limit microbial contamination, basically at this step, we just want to ensure alcoholic fermentation and limiting the yeast stress. So we did other previous webinar on yeast nutrition, so I'm not going to detail too much on this, but basically to have good management of alcoholic fermentation, you want good yeast nutrition with a balanced diet. You also want to limit the stress, which means good nutrition again, but managing temperature, turbidity, survival factor, and oxygen. And please be proactive and not reactive. So observe your kinetic and try to understand what's going on with the yeast and read what the yeast is telling you, if the yeast is stressed or not. Okay, the second aspect of bioprotection is arriving to malolactic fermentation and inoculation or not. So once alcoholic fermentation is completed, so Saccharomyces population are going down, then the next population that is going to come up are malolactic bacteria. Okay, here is a very big risk because that's the step where any lactic acid bacteria and also Brettanomyces, so any Lactobacillus, Pediococcus, Enococcus, and Brettanomyces will be present and available to develop. They are actually responsible for most of the microbial spoilage in wine during aging. And they are very happy in this environment. When Saccharomyces goes down, there is no more protection. We arrive to this microbial vacuum where it gets risky. Okay, when you let it go wild, and there is many wild malolactic fermentation that can work, but the risk that you are taking is to have Lactobacillus or Pediococcus or the wrong strains of Enococcus that will develop, and you will end up with wine that smells like cheese, horse, tastes like mousy, like tastes like a dead mouse in a cage, tastes or smells like fish pond, stagnant water, algae, and also vinegar. You take a big risk to have a strong or high level of biogenic amines production, which is the one that smells like fish flake, fish food, aquarium, stagnant water, and algae, but also they are unhealthy and responsible for cancer and problem with human health. So you do want to control this. And another point that is very important, that it's very hard to remove this off flavor once they are in the wine. So to avoid this, again, we want to make sure we are controlling which population is fermenting and dominant. That's the last fermentation we are going to do. And for this, I highly recommend to inoculate with a commercial yeast bacteria. So I'm going to talk about the NO1, which is a Lamottabier bacteria that has been developed and selected for resistance to difficult conditions, that is basically used for co-inoculation or curative inoculation that can be in low pH or high alcohol wine, red or white. It will be it's a bacteria that doesn't produce diacetyl, but produce more esters and acetate and just have a short lag phase and a strong dominance, so it just ferments very well. But in general, inoculating with malolactic bacteria will help you control microflora balance and make sure you don't have all this off character because you have the proper yeast, a proper bacteria, limit risk of contamination, secure malolactic fermentation, limit biogenic amine production. NO1 does not produce biogenic amines, limit off flavor production, and limit production of SO2 combining molecules. NO1 can consume acetaldehyde, improving basically the efficiency of sulfur after malo. So here is a graph of the biogenic amine production, NO1 versus wild fermentation. You can see there is a huge difference in terms of amount of biogenic amine produced. Okay, so that's a very important point. And if you want to know more about NO1 and co-inoculation, please watch our webinars that you can find on our website. So once malolactic fermentation is done, that's where we are changing our approach, and we're not talking anymore about equilibrium of population, but we're talking about pure protection of the wine and eliminating microbes or make sure they don't grow. So at this step, we usually use sulfur for antioxidant and antimicrobial purpose. We have alternative for both of the actions. So as on grapes, antioxidant can be rich with tannins, ascorbic acid, or glutathione or sulfur peptides. Managing pH, temperature, and also redox potential can help. Antiseptic, which is where we are going to focus on right now, will be achieved with microbial competition, Chitosan, or lysozyme. So we do have 4 options at this step. Now we are not talking about managing population, we are talking about making sure they don't develop and eliminate them. So for this, we can play or use lysozyme. Lysozyme is a protein extracted from egg white that will kill lactic acid bacteria. So it has a strong effect on Lactobacillus, Pediococcus, Onococcus, but that's it, not on the other microbes. Okay, so very efficient antimicrobial effect or antibacterial effect. It also has some side effects such as it's a protein, so it does react with color, it drops color, and it also requires more bentonite in white wine. And then it is an allergenic compound. Okay, Chitosan is my favorite molecule. So Casey talked about Chitosan, he used it in his trials, and as he was telling us, it did work very good to control microbes. So I will talk a little bit more about Chitosan now. Then filtration and DMDC, this is mainly pre-bottling because you're not thinking about filtering your wine and then aging it without lees. That's not really an option. So you do want to filter sterile before bottling if you want to manage microbes. And then DMDC or Valcorin, this is an anti-yeast agent and it does kill the yeast, so it limits the development of Brettanomyces or Saccharomyces in a sweet wine. So that's a very good agent if you don't want a re-fermentation in your wine. Then let's focus on Chitosan because it is, outside of being my favorite molecule, it is the best microbial agent you can find in winemaking. It's a wide spectrum antimicrobial fining agent. So Chitosan is coming from the deacetylation of chitin, which is a polysaccharide that is in winemaking derived from Aspergillus niger. So it is allergen-free. And you can see the chitin is here, and we are doing the deacetylation and making it in a charged condition. So we do end up with Chitosan that is a charged molecule. Charged polysaccharide that is positively charged and will attract the microbe cell walls that are negatively charged. So as you can see in the picture on the bottom of your screen, there is this attraction, which is like a magnet, where on this case, Brettanomyces cells are attracted to the Chitosan that will, as soon as they touch each other, the cell walls of the microbes are actually deteriorated, which lead to the death of the cell. So when and how do we use Chitosan? So it is a vegan allergen-free fining agent that doesn't stay in the wine. You can control malolactic fermentation. You can avoid it or stop it. You can remove spoilage microbes and you can prevent spoilage microbes as well. So prevention means you are adding a low dosage, such as 2 grams per hectoliters in your wine. That's what Casey did. Very low dosage just to remove any microbes that could be present, that could develop and produce spoilage. So you remove them before knowing even if they are here or not. It is like kind of a health insurance. You just put it and make sure they never develop. If you do have a contamination, you can remove spoilage microbes. We are talking about much higher dosage, 4 to 6, actually up to 8 grams per hectoliters. And this will remove the microbes. This treatment for contamination requires racking of the leaves after this. Lamotabier developed a pure Chitosan product that is called Kilbret. So Kilbret is our pure Chitosan product that the dosage I just told you about, 2 grams per hecto with prevention and 4 to 6 grams per hecto contamination are associated with the Kilbret. So we can use it as a curative. to eliminate microbes, and in this case we will do a racking as soon as it settles. So it takes a little bit to settle, but then when it settles you remove this lees of dead microbes. As a prevention means lower dosage, we kill whatever is there, we can leave it on the lees, no problem. We realize actually with several studies, that it's still active 4 months after the treatment. 4 months after the treatment, we still have a low population of Brettanomyces, even when we do contaminate it. And also what we realize is this population is actually having an affected metabolism and doesn't produce as many volatile phenols. So even after 4 months after treatment or with Kilbreth, we change the metabolism of Brettanomyces. So they could be alive, but because of further contamination, but they will not produce as many volatile phenol. Then the last point is because Kilbreth is a pure chitosan, we are using very low dosage, which actually means that we have a very limited impact on the organoleptic profile. Okay, so if you do have more questions on the application of Kilbreth, I'm very happy to answer them. And also, like, please email me anytime. That's a product that is more for like wine treatment and wine preventive than on grapes, since on grapes we have the BioNature that is, I think, a better application. So conclusion on which antimicrobial we can use and when. So obviously sulfur has to be resonated with pH and temperature and can be used anytime. But since we are talking about alternative to sulfur, on harvest or grapes, for grape control, we can use BioNature, lysozyme, or Kilbreth, chitosan, even if I think BioNature will be the most applicable at this point, and which makes much more sense. During fermentation, we obviously want to control fermentation very well and have a proper yeast nutrition. And then once we arrive to stopping malolactic fermentation or inhibiting it, lysozyme or Kilbreth will work. And during aging, we can have lysozyme, Kilbreth. We can always filter, that could be an option. Pre-bottling, sulfur can be an option. But again, lysozyme, Kilbreth, or filtration. If you do want a wider spectrum, what I would recommend is to use Excellence BioNature on harvest, always play with pH and temperature, and then go on Kilbreth for the aging. In this way, you actually replace sulfur with only allergen-free compounds, and you're having a wide antimicrobial spectrum that allows you to make wine without being spoiled and without sulfur. Then to finish this presentation, I also, since the presentation is about reducing sulfur, in the objective of reducing sulfur, I would like to speak a little bit about how we can optimize sulfur. So when we do add sulfur, probably after malolactic fermentation, we want to make sure we have an optimized effect and we can reduce the amount of molecules that combine sulfur. So we optimize the amount of free sulfur we have. For this, we know that using Excellence BioNature on grapes instead of sulfur will help, having less acetaldehyde and less basically sulfur combining molecule. Also limiting the yeast stress, because yeast produces compounds when she's stressed. We know that using steam at rehydration, which is a rehydration nutrient, help the yeast to reduce the stress and produce less molecule combining sulfur, so combining with sulfur. So you can watch our webinar on yeast nutrition to have more information on this. Co-inoculation with NO1. So the co-inoculation approach help you to limit the amount of molecule that will bind with sulfur. And also NO1, the choice of the bacteria. NO1 is consuming acetaldehyde, so will help you having less molecule combining sulfur. Last point, if you delay your sulfur addition after malolactic fermentation of few days, you will combine less. So you can always use lysozyme or Kilbreth, chitosan, to stop malolactic fermentation, make sure you are clean, then you do a racking, and then you can add sulfur for stabilization of the wine.